YouTube channel. In this video, I'm going to show you on Form 4 Physics, Chapter 2, Part 5, Resolution of Force. Just as what you have gone through in the previous video on getting the resultant force, before we get into resolution of force, you need to have an idea of the vector quantity of a force. Well, in the previous video, we will get to learn, in order to get the resultant force, the method I'll show you is the tip to tail method, or tail to tip method. We'll talk about tail to tip method. This is where, if you were to have one force to the right and then another force going up, the tail connect to the tip. So this is the tip, so this is the tail, right? So I'm going to write it down for you. So this is actually my tip, is connected to my tail. Well, force is a vector quantity, so make sure you have your arrow. The second force, this is my force 1, this is a second force. They are tangent to each other, 90 degrees to each other. Then therefore you get your resultant force. So my resultant force I've shown you earlier, that will be, okay, you connect them. This is like this is like, well, from here you walk to the right and goes up. So it's analogy from here, walk to here. Okay, so this point, this is where my resultant force, and also this is where the angle. So all you need to do is make use of Pythagoras theorem to look for this magnitude. Then of course from your book you may have another method. I'm not going through it here again, but I just want to highlight over. If you've gone through your text, it is called a parallelogram rule. The parallelogram rule. This is what happens when the force is now no longer, not necessarily 90 degree, then you need to use parallelogram rule. The method is quite similar. It's just that now if you are given two forces, one to the right and then at a point another force act on the same point. Maybe there's an object or a ball here, or maybe a crater or a trolley. Okay, so how to solve it? With an angle with each other. Okay, so how to solve this kind of question, that you need to look for the resultant force. It's related to resolution force, because now the force are no longer tangent to each other, meaning tangent is they're no longer 90 degrees to each other. So how to do that? That would be, first you need to transfer them into diagram. That would be if you have two force, so one going up, F2, another force going to the right, F1. Now what you're going to do is you need to transfer, okay? You copy this force and this force, transfer it over here, so that you get the tail to tip rule. Okay, this is to here, and then this is to the horizontal, and then you connect adjacently. Okay, so this is actually the resultant force. Okay, this method is what you call it as a parallelogram. Okay, and I'm sure you have heard of this from your additional maths, or perhaps the modern maths. Okay, so I'm not going to dive into it, but what you need to know is about the perception of the maximum minimum, or vector or a scalar. Let's say for a scalar, if it's a scalar quantity, or if it were to be a scalar quantity, okay, let's say you have two values. You have 2 centimeter, a length, okay, 5 centimeter. The perception of it, what's the maximum minimum can you get? The maximum, of course, you will get will be maybe 5 plus 2. This is the maximum you will get. This will be 7 cm. How about the minimum? Okay, minimum minimum length would be what? Since it's a length, maybe that will be only 5 minus 2, 3 cm. You don't expect to be a negative 3, because length, how can you be a negative length? It cannot be a 2 minus 5, because the perception of quantity is just about magnitude. So that's the maximum, that's the minimum you get. You can never have a negative length unless it were to be a vector quantity. You have direction. Now, for vector quantity, say for example, now I don't want to use length now, I want to use force. In force, in order to represent it in diagram, you use arrow. If this were to be, no, I want it to be horizontal only. I have a force to the right, 2 Newton. You're given 2 forces, 2 Newton and 5 Newton. Please take note, 5 Newton is, the magnitude is definitely longer than 2 Newton. That's why the magnitude is represented by the length of this arrow. The head represents the direction. So both in arbitrary direction, in any direction. Okay, what's the max and minimum you can get? From here, I would deduce the maximum is when they are moving at the same direction, right? If they are at the same direction, whether it's on the left or to the right, that would be 2 Newton to the right, and then 5 Newton to the right, 2 Newton, 5 Newton, maximum I'll get 7 Newton. This is the first case, maximum. That's why I'll get 7 Newton to the right. For minimum, well, you might say minimum, that would be the smallest possible. Maybe 2 Newton minus 5 Newton, right? So one's to the right, 2 Newton, and then maybe 5 Newton to the left. Now therefore you get a minimum. This is what you have, negative 3 Newton. But it's not really minimum, but it's just that the sign here, in terms of minimum, in terms of magnitude, the sign represents its opposite to what we have defined positive, which is we define positive to the right. Redefine it. You need to define where is a positive. Which direction is your positive direction? So when it's negative, meaning it's moving, is opposing, the direction is opposing to what you have defined positive. Okay? This is important, especially when you deal with the force. Which direction is going? Okay? I hope you're still with me. Let me give you another example. Not example, let me go into resolution of force. Now, in order to resolve a force, resolution of force is actually resolving a force. Give a scenario. It's easier to learn by example. Resolution of force, what does it mean actually? If it doesn't really know what's meaning, then you're going nowhere. Okay? What does it mean, resolution of force? It means you need to resolve into 2 components. You need to resolve into 2 components. Component of force. Well, it doesn't need to worry much about this word components. What does it mean by components? Give you an example. Like what you have done in the previous video on resultant force, right? Now, you were given, oh, okay, I have one force. This force is going up 5 Newton from the horizontal or horizon, making an angle theta from the horizon. Now, this is not neither horizontal nor vertical. In order to resolve into 2 components, what you need to do that would be you drop a perpendicular line down to the horizontal, as well as, well, this is parallel, as well as an horizontal line. You draw two lines on it. So what you need to do is you need to find out what is the component force. The component, it means, is the x and y component. The component is the x component and the y axis. Sorry, the y axis. What is that component? Okay, you need to find out what's the component in x and y axis. The trick is, if you draw a perpendicular line, this would be eventually your x component, and if you do it correctly, the x component, the length, the magnitude of this length will always be perpendicular to it, meaning it's shortest. It should be shorter than the 5 Newton. Okay, you need to find this value, and the vertical component, which is parallel in parallelogram, which is here, because you may transfer this force to here, so that you get a triangle and you get perpendicular. So if you're given only 5 Newton an angle, so the vertical component, or this is also sometimes called as horizontal. You need to learn this word if you doesn't know what does it mean. Horizontal component, whereas the y is vertical component. I think it's easier to put it this way. Vertical component. This could be a new word for you, but this horizontal h is the one that's in the x-axis. Vertical is the y-axis, y. Yeah. So how do you get it? Okay. In order to get it, you need to make use of. Well, in order to find out what this is actually, here to here is cos, right? 5 cos theta angle, whereby the vertical component would be 5 sine theta. Maybe you have forgotten about the sine cos tangent. It's about time to find out now, to learn back what you have learned, to get back what you have learned in the past in trigonometry. If this is an angle, this is A, this is B, this is hypotenuse length, h. So your sine h theta is actually opposite over hypotenuse, A over h. So if you want to find out what's A, so therefore my A is h sine theta. The same is true with cos. For cos theta, that would be B over h adjacent over hypotenuse. In order to find what's the B length, therefore that will be h sine, oops, not sine, it's h cos. Okay, it's a revision for you if you have forgotten about this, because I need to find out what's this component and this component. The same goes here. Then you have resolved them into, you resolve this force into own component. Then next question would be, why is it important? Right? In reality, it's not always the case that you get horizontal or vertical force. Sometimes you get force pulling you at an angle. Let me give you an example. If a trolley, go to a supermarket, you have a trolley. A trolley in the supermarket. Well, assume that the floor is smooth so that there's no friction. The mass is 5 kg. It's always, if you want to work out this working, it's always true that if you pull this trolley, it's so much easier than you push, that you're pushing it. Okay? So, now, if you were pull on it, I'm not floating, okay, alright. on it and an angle, of course the object should move to the right. Okay, just give you an example. Now, and the direction of, if you know your height, okay, if you know the length of your hand, then definitely you will have an angle. So the angle for it, if you transfer it into a diagram, okay, so this is the angle theta. Okay, so this is the direction of force. Right? So you actually be able to find out, okay, since this object would have 5 kg going downwards, that would be MA, the weight caused by the gravitational pull would be 5 times 10 Newton. 10 is acceleration of gravity, acceleration 50, and this trolley will definitely not going up or down. It will only move left or right. For this case, it's not going up or down, so therefore pushing down is the same as with the normal force, or reaction force, third law of Newton. So it's 50 Newton up and down. That's why this object is balanced along the vertical component. Next, we'll have left and right, right? Because it's moving to the right. So if it's moving to the right, therefore the net force would therefore be well, I need to know, says whether let's say I'm pulling at 35 Newton. Okay, what's my vertical component? I'm going to put it into this diagram, triangle. This is theta. This is to the right, 35 Newton. You doesn't need to worry about the vertical component. So you worry about the horizontal component to the right. So this would therefore be 35 cos an angle. So if you manage to find out this, then yes. And of course, this is the 35 sine theta going up, but it doesn't need to worry about this, right? Now, the same problem, what happened is the floor is no longer smooth. There are certain amount of friction, and the frictional force, or you call it as a dynamic friction, is actually 8 Newton to the left. The angle between the horizontal with the force of 35 is, says 25 degree. This is now 25 degree. You are now asked, since there are friction, it's going to accelerate. Now, what's the acceleration? The rule is, if you have friction, then you're going to have acceleration. So what we'll do now would be called free body diagram. The rule for the free body diagram is, first, you assume everything is in a dot. This is the object that is moving, 5 kg. So it's represented by a dot, 5 kg. Okay. Now, first of all, you know that the horizontal component to the right, well, doesn't know what's the magnitude. This is the arbitrary length. Is 35 cos 25 degree, and this is the result from what I have, 35 25. Okay, because I found it early here, so I will just transfer to here, to the right. And friction is to the left, so maybe to the left is only 8 Newton. Up and down doesn't need, but it's a good practice since we are doing it. So this magnitude is actually 35 cos 25. Oh, not cos, sine. Okay, and this is my mg. So obviously here you doesn't know what is the mass. This question, for this question, the friction is to the left. What is the mass? Maybe they'll ask. So here, since up and down is the same, therefore, if they ever ask, okay. So therefore, 35 sine 25, that will be mg. Right, but since they never ask, then let's not get into it. It's an equation for friction, okay? So let's not confuse you with that. So no, let's not got into that. You get to learn, okay? The vertical component once you are in your degree or pre-U. There's an equation for friction. There's a coefficient of friction. You get this 8 Newton, then you get things from there. But for now, since you asked for acceleration, this object accelerates to the right. You need to learn how to draw this sketch this free body diagram. This is what you call the free body diagram. Therefore, from a free body diagram, you'll be able to get the equation to the right. So all you need to do, I define positive to the right. So first, this is my to the right quantity, 35 cos 25. I just copy from here. Minus, this is to the left, that's why it's minus 8 Newton. And it is equals to, I think I come back to 5 kg, 5A. Because we are not doing the frictional part there, okay? So just let you know what's the 8 kg, 5A. So therefore, from this equation, solve this. Therefore, my A would be this number. Make sure your calculator, if you're new to your calculator, make sure you can see a degree. Make sure the cos is a degree. How do you do that? You change the mode. Make sure it's D, okay? 35 cos 25 minus 8. Answer, divide by 5. Then the answer should be 4.7 meter per second. Right? So free body diagram. Then, well, maybe another example. Would be on a scenario, a box, top view of a box, top view from a top view or a bird view. This box is pulled by one person to the right, 12 Newton, and then another person pulling it over the left hand side, 8 Newton, and this force is no, let's get to that. And the direction of the two person, the direction of these two force, they are not. I'm going to draw it again. Redraw this into free body diagram perhaps. Maybe a box in the middle, force 12 Newton to the right and another person's pulling at 8 Newton, the angle between them is 120 degrees. You are asked to find out what's the resultant force and which direction would this box be moving. Okay, so first of all, you resolve the force individually. So this one, that's horizontal force to the right, so it doesn't worry much. All you need to do is the 8 Newton because it's an angle. So if it were to be the horizontal, it's always need the horizontal reference, so it will be 60 degrees. And XY axis you need. Therefore, you know that from here, if you drop a perpendicular line, this magnitude to the left would therefore be 8 cos 60. Now, this is really take some time for you to look at it. How do you know it's cos? Is here to here is cos. Therefore, the one up to here, or this here, equivalent. This one here is equivalent to here. No doubt. That will be 8 sine 60. Okay? Then it's quite straightforward now, because from here, one is to the left, another to the right. All you need to do is find out whether this force is actually the net force. Net force is to the left or to the right. Okay? So you need to redraw this diagram. Going up is, of course, to be sure, of course, is 8 sine 60. Now, between 8 cos 60, if you have a calculator, that would be half. So it's 4 Newton. Okay? How am I so fast to find what's 4 Newton? Because I know this is actually 8 half. That's why it's 4 Newton. 4 Newton to the left, 12 Newton to the right, therefore the net would be actually to the right, 8 Newton. No magic, it's all about trigonometry. So it's one force to the right, one force going up, by either method that I mentioned earlier, either parallelogram or the previous video that I showed you, the tail to tip method. I'll show you the tail to tip, so I'll show you the parallelogram. This is to the right, this is going up, so therefore connect this point to this point. This is where the resultant force, FR, resultant force, capital, with an angle horizontal. So in order to find out your FR, that would be square root of 8 squared, Pythagoras theorem, yes, plus sine 60, well, this is not a very good number, because sine 60 is root 3 over 2. Root 3 over 2 squared, okay, Newton. Use a scientific calculator, we should get a value of, I think, 10.6 Newton. And the angle, this angle, degree, here would be, instead of using this value, I will use tangent, arctangent, this magnitude, it's sine 60 magnitude by 8 Newton, and therefore should be 41 degree from the 12 Newton. 41 degree with respect to the 12 Newton force. Okay, so this is actually how you resolve two forces. For this case, it's a bit tough because there are two forces now involved. First, you resolve this force, it's an angle, you need to resolve it. Then you subtract here to here. Because one is to the right, one is to the left, then the net force is 8 Newton. How do I do it? In theoretical particulars, you have this standard angle. Okay, I think your maths, or the maths teacher perhaps, if I have 60 degree, 60 degree, 60 degree, I bisect them, meaning they have 2 cm, 1 cm, 1 cm, this is 60 degree, 90 degree, then this one here is 30 degree, 30 degree. Now if you have this triangle, it will be so much easier to find out what's the value for maybe sine 30, sine 30, therefore that will be sine 30 is 1 over 2, cos 30 is, this is 1, this is 2, this is root 3, right? This length 4 minus 1 is root 3. Cos is root 3 over 2. Okay, you may set up a table, find out what is the sine cos tangent for 30 and 60, and maybe a 45 degree. The same triangle, you may use it. If you have 30 and 60 standard angle, for 90 degree, then all you need to do is to get (45 degree), 45. So the length here 1, so this is root 2. Sine 45, sine 45 is 1 over root 2. Cos 45 also root 2. Root 2. Okay. You may need to pause this video and then set out a table. Maybe give an example. Table of sine, cos, tangent, standard angle. I think I've shown this in my additional maths video on sine cos trigonometry. That one comes with a 0 degree, then followed by 30, 45, 60. Okay, from these two triangles, you should be able to set up a table. Okay. I don't mind to help you out with that over here, just in case I've forgotten those values. So sine 30, that will be 1 over 2 half. Sine 30, 1 over 2. Sine 45, then you refer to this video. This is a triangle. Sine is 1 over root 2. Sine 60 is root 3 over 2. That's what I have here. Then cos 30 is root 3 over 2, because cos 30 is actually sine 60, same value. Okay, and this value is 1 over root 2. Cos 60 is 1 over 2. They are always his value. Cos 60 is equivalent to sine 60. Sine 60 is equivalent to cos 30. The same is true. Sine 30 is equivalent to cos 60. Same value. Okay. Tangent. Okay. For tangent 30 is 1 over root 3 value. Tangent 45 is 1. Tangent 60 is root 3. Okay. This is one of the table. It helps you. Okay. You will need to stop this video, and then with this table, it helps you to solve problems. You need to try to at least learn how to resolve questions on resolution of force. Maybe try maybe 5 to 8 questions. 5 to 8 questions. Yeah. Find out if you have what happened when they are friction. Whenever they are friction, then therefore they are going to have acceleration. Okay. I think I'll stop here. You need to get back to the another video for pulley system. In Pulley system, I will need to use free body diagram as well. What you need to do now is to stop this video and then try at least 5 to 8 questions on resolution of force. With that, stay tuned to my next video.